Good afternoon, University of Chester and University College Isle of Man. This is the first of probably three short tutorials on what is Ambari, what is Hadoop, what is HDFS, what are the tools that it uses and how does it use them. So this is a demonstration space for those people that haven't managed to actually get their hands on this tool set yet to actually see what it actually does and what it's all about. This is a supplement to the lectures. Richard and I are both going to be giving lectures to UCM and University of Chester respectively. This is not to be seen as an alternative. Most definitely this is something you need to look at to get a better feel for what this weird thing called HDFS Hadoop is, because it's not straightforward, it is complicated. But hopefully we have created a lecture series that first of all gives you the lectures, and then gives you the workshops, the written workshops, and then gives you some supplementary application space to show you what these tools actually do. And we'll put these on the Moodle site or via links from my YouTube account or thereabouts. So what are we looking at? You've actually got a screen in front of you here, which is just a web interface. I built last year what we call an Ambari Hadoop service system, just on a single machine, a Mac Pro 2012 with 128 gigs of RAM, dual Xeon chips, culminating in 24 threads of execution. So it's quite a powerful beast. It's about the most powerful one they ever produced up to that point. It became very useful to actually produce something with using Ambari. Prior to Ambari, you could install Hadoop the way you wanted it with all the tools, but it's really complicated. It uses pure command line interfacing, which means you're working at the back end of Linux, the whole space. And if you're not comfortable with that, that's complicated. I do recommend you learn it because it's a very valuable tool set. But actually, it shouldn't really be part of the course. This is part of the course just to show you what this tool set actually does. This is the first cluster I ever built. I built this Christmas 2018 or thereabouts over that holiday season. Stack of 4 Raspberry Pis, not particularly powerful, not much RAM, only about 4 gigs of RAM. But it did the job. And I got students to build these as well as part of the program for last year, but it did become a headache using command line interface. So now we give you Ambari. Now Ambari is another open source package, as is the entirety of the Hadoop ecosystem, and it manages the Hadoop install and manages Hadoop full stop and all of the tool sets as well. So you've seen this in the screen in front of you. This is actually a client access. I'm actually using my other computer here to record this. So I've accessed what I'm showing you here now via the web interface. What you actually see here are an overview of everything that's going on in my service install right now. So I click on my dashboard and it brings up here, for example, where my mouse is running over here, HDFS disk usage. This tells me how big my service is. Now imagine I'm Azure and I've got 50 million of these devices, but much bigger ones, all attached together with usual networking cables and connections. Each one will have a drive space for storage of some description, maybe 3 or 4 terabytes each, and I maybe have 20,000 customers buying a Hadoop service from me that interacts with that system service. As a manager, what I'm going to want to see is just how much of my disk space is being used in that space. In this system that I'm running, only 7%. I've got loads left. That would give me a nice, comfortable overview that everything is running okay. It shows me also how much CPU time is being used here. It also shows me the network usage and what the throughput is, and total RAM memory usage as well, which is important too. Don't forget, a lot of the applications that we use that are RAM specific, they don't necessarily use hard drives. When we come to do some machine learning demonstrations on this in about 3 videos time, everything is done in RAM space across the cluster, which means you need to know how much RAM is being used on each of those machines as well. Ambari has been a lifesaver in terms of both the development and the management of everything. Every time I make an adjustment to it, it allows me to collect all that information. It also tells me if I've got any what called heat maps or heat spots going on here where something's being overused. So it tells me if I'm running short on resources at some part of the system. And so it tells me basically I need to grow my system a little bit. But it captures all sorts of really interesting stuff relating to this as well, such as my individual tools and how much they're being used. We're going to be covering Hbase as an alternative to SQL databases shortly, and I'll show you some code for that in another video, and this tells me basically how much of that system is being used. In fact, each of the tools here are just that. So I'm rolling my mouse down the set of tools I've got installed in this particular install. There are many more tools than this. It's a vast ecosystem, Hadoop. I'm just going to demonstrate a few of them to you. First of all, HDFS, that's the place where we store data. It's the Hadoop Distributed File System. The solution to what that is in the name. Distributed File System. It's a place where we store files. It's distributed across, you guessed it, multiple machines. And so I'm going to show you what that looks like. Businesses now have a terminology. It's a bit flaky. It's a bit like cloud. They call it the data lake now, because this is where businesses actually store dominantly all of their data. For those systems that have gone to Azure Hadoop, for example, they're now dumping in SQL files, CSV files, text files, social media outputs, semi-structured files, JSON, XML, anything they store, even just Word documents, get dumped into what we call the data lake. And that's because that centralizes all of the business data, which then analysts can come in and harvest outputs from. And so this is what it actually looks like. This is the overview of the data lake, essentially. This tells us here, notice I'm just accessing this through a web interface, as usual. This is what the whole of the Apache thing does for us. It allows us to have nice, easy access points. It tells me how much of my data file system is being used. In this case, I'm using 4 gigabytes. Not really big data, I know. But it also tells us how much space we've got remaining. In this case, I've got 372 on this partition remaining to be used. It also tells me there are no problems. Security is off, safe mode is off. Everything's running the way it should be. Customers, users, other programs hooking into it should be able to access and drop in information and pull it out if they have the permissions set. I can actually look at the data lake as an administrator as well. So I'm going to browse the file system here, and this is what it in part looks like. And I'm just going to cover all of these bit here are file stores for the individual tools themselves. I won't be able to access those. I can access some of the user data though. I'll just slide that over a little bit. If I click here on my Ambari data, I can actually show you some of the data looking to be installed here. So here's a patch of different sorts of data, CSV files, GZ files, that kind of thing. Each is a different size. If I had it set on a cluster, and my Mac Pro is not actually a cluster, that would have to be multiple machines, I could set it to, if I had 3 machines, I could set it to replicate the data on all 3 machines identically. That's dead useful, because that means I've got my little Raspberry Pi cluster here, and I pull the plug on one, pull the power, everyone still gets access to that data, and that's key. It builds a resilience into the system, so it doesn't matter if you have a technology failure, your system should be able to, if it's managed correctly, should be able to pick that up. And so you can look at some of this data as it comes through here. I think I've got a permissions problem on this one right now, so I'm not going to be able to show it. It's not going to let me show it to you. It runs on Linux permissions, and I've got something going on here, which means I can't show the context of data. But if you own that data and you had the permissions, it would let you see it. And so, yeah, it's the data lake is just where you store all the data. It could be text files, CSV files, all of these files that you see here, and you can almost imagine them being continually written to by web interfaces, that kind of thing. If you're a business, you receive 1 terabyte of data a day, it just naturally fills into this data lake space and can be used over and over again. When we're actually running analytical work on that data, which is spread across your cluster, we also now need to have a gadget or a machine or an application that manages that properly. What you don't want is a situation where you have a couple of nodes running and they just get continually hammered with another machine not being used very much. And so we have this thing here, and it's called another resource negotiator, or YARN. It actually manages the resources for us. It tells us how much RAM we've got in the total system, what's currently being used, and how many what we call containers are being used to run it. And a container is just a Java container, really, which contains the Java code, the data that's going to be used, which will be stored locally on the local machine, and the drivers required to introduce it, depending on what tool you're using, whether it be Tez or Spark or something like that. And I'll show you one of these applications running in about 2 videos time. You can see what it actually, you can get a feel for what it actually does when it runs it. But yeah, think of that as being, we call it yet another resource negotiator. It's the tool set that basically makes sure that the work is distributed fairly and equally across the cluster. You've got to see it from the context of a big data job, like Azure's implementation, for example, where they might have that 20,000 customers accessing it. Everything has to be managed in an organized way so everyone gets an equal ability to run that service. Yarn is the thing that does that for us. And of course, it's got a management interface like all the other tools, which lets us make sure that everything is running. Nothing's being overused, and it tells us how much RAM is available to use. 89 gigabytes, plenty there. So it tells you that the operating system's keeping some for itself and then telling Yarn what it's allowing it to use across the service cluster. We have what we call MapReduce here as well. Doesn't give you much management here, which is nice because it just works in the background. Imagine a job where I've got 40 million rows of data. It's spread across 3 nodes of the cluster, each of these things here being a node. I get it to calculate those calculations locally on the cores, and then it MapReduces the final result out to the user. You don't have to go into it any more deeply than that. We have Hive here, which we'll be looking at. Hive is a data warehousing toolset. And as I say, I'll show you a demonstration of that and what that looks like. I'll also show you an Hbase, which is more like a NoSQL databasing type system. Very simple coding characteristic, but I'll also do a command line interface demonstration of that for you. And later on, I'll do a Spark 2. This is my pride and joy. This is what I love doing. Machine learning. This is big data machine learning, where I can harness all cores on my cluster and bring data back to the user in a way that's just very timely, very quick to produce, although at the complexity level, which is very high, and I'll describe that to you when I show you the code. Well, I hope you've enjoyed the first video introduction to what Ambari is in relation to Hadoop. Ambari is a manager of Hadoop and all of its tools. It helps me install the tools, remove them, update them, add users in, that kind of thing. The next demonstration I'll be talking to you is about Hbase, which is one of the tool sets we use, which is a NoSQL database, which enables us to store data in a highly efficient way, in a way that's far more efficient than a SQL database. So, many thanks for your time and effort on this. Feel free to review this video as frequently as you like.